an important part of every design. But if it is the dominant part and it begins to over-dominate, you ain't gonna get anything done. If we have to package people in a small capsule and put them under a tractor rocket before we're willing to send them to space, we're going to handicap people for a long time. And we didn't handicap them here. And we've had 30 years of flying this thing, and the landing has not been a problem. So, was it a dumb decision? I don't think so. Was it a gutsy decision? I don't know what really gutsy means. It was not an unreasonable decision, which is my criteria. Any other question? Excuse me. Go ahead.
Yeah, you mentioned you had a choice between on the external tank between an internal thermal protection and external thermal protection. Can you describe what those traits were?
Okay, the question was, why didn't we insulate the tank internally rather than externally? It's a good question. If I had that question to answer today, I might have looked harder at internal insulation, knowing that we sat around and waited till enough of it came off of the tank to give us a problem. But the basic thinking at that time was the internal insulation, if it comes loose and gets in the engine, you've really had an engine shutdown problem at minimum and maybe worse. We also did a lot of work, maybe not enough, we did a lot of work in what we used to call the ice follies, trying to be sure we had nothing in the way of ice or anything on that tank in front of the orbiter that might cause us a problem. The little beanie cap that you see today that lifts off, that was put on there late in the program to make sure that that cold gas coming out there didn't form hard ice at that part of the vehicle that might cause some problems. The fact that with that closeout area at the pod on the nose of the orbiter where it goes into the tank, the fact that we sprayed insulation on there other than the kind we put on the factory under close quality control, that was a potential problem. We should have known better. Also, we did not need an aerodynamic ramp there, the fact that that thing slanted up like that, because we had refused to put an aerodynamic ramp around the whole thing that a lot of people wanted to do because we didn't feel we needed it. The external insulation was a fairly easy decision for us that time because we didn't want to go to the, it's very expensive to try to insulate the inside of a tank and do it in such a way it doesn't come loose and get in the engine. It's pretty easy to set the tank up and spray insulation on the outside. In retrospect, what we should have done is not had that spray-on insulation on the closeout. Should have put a heater there in the first place, and we know that now. It costs a lot to learn that. Those are what we call infant mortality problems, things you learn when you start flying something. Just like we learned that maybe those seals, those O-ring seals weren't doing as much as we thought they should. When you started getting some data from flights that there was some blow-by. Blow-by on a O-ring seal is a bad set of news, any blow-by. And then the vehicle flexes and moves differently in different launch conditions, different winds. And if you're not careful, if you launch on a very cold day, when the O-rings aren't sealing the way they should in the first place, and they're colder than they should be, and the winds are high on that day, and the tolerances add up, you get an education. It costs you a lot, but you get an education. Those things are called infant mortality. Today, the orbiter flying today with the solid rocket booster joints and seals as they have been redesigned, with the external tank insulation having removed that aerodynamic ramp in the front of the orbiter, having done all the other things that I don't even know about that they've done, the orbiter they're flying today should be by far the safest system that's ever been flown, an orbiter. And if I fix those two problems, I've had, what, 130 pretty good flights. But we weren't smart enough to find it in the design, and we didn't fix it when it began to show up in flight. That's just part of life. We've got another question.
about the hypergolic propellants for the Olds and the RCS.
Hypergolic, oh. Well, yeah, basically you don't want to try to have cryogenic propellants on orbit. So you have to go to some sort of propellant that you can take to orbit and have it there a long time. You'd like hell, Guy's here, he can answer this better than I can. You'd like propellants that ignite automatically when you mix them. And those propellants were just sort of picked up out of common sense out of the Apollo program and other things. Guy, you want to add to that? Hypergolics make sense on orbit. Now, I see we're beginning to talk a little bit about fuel depots in space. I don't know whether those things are going to be very practical or not. I don't know whether you can insulate a tank well enough to take cryogenic propellants and store them for a long time in space and still live with the boil off you get, or put an active refrigerant system on it, whatever. But I think we ought to begin to do some technology on that, because there's some things about flying out into space that if you could put fuel depots here and there, you could maybe improve the way of doing things. I don't think we're going to go very far if we have to come all the way back to home with a system where we have to have the ability to enter the Earth's atmosphere at the same time we have the ability to land on the moon. We need to separate these things a little bit and not stack all of our problems up. We don't insist on the 747 taking us home when they come in. It takes us to some place, then we come home in the shuttle plane or we come home in a car or something. We haven't necessarily thought through this thing very carefully.
Could you say a little bit about ejection seats, when we had them and when we took them off?
We put ejection seats in for the 4. It's another, I'll answer your question this way. When we set up the shuttle program, in our budgeting activities, we chose a term that says, this is DD&T and this is operations, for budgetary reasons. We didn't mean operations mean you can put Joe Blow on there and he's not at risk and go fly, that it suddenly became operational. That was just a term and thing. But what we said is for the first 4 flights, we'll only put 2 people on board. And we can put ejection seats in for 2 people. But when you start putting people down below, you don't like to fly on an airplane where the pilot's got an ejection seat and you don't. Most people don't, and we didn't think anyone would. So we couldn't put ejection seats. We could put seats exploding down below. But again, let me tell you, when you deal with the so-called rocket equation, and Owen can help me, these numbers probably escape me right now, but if you count the actual payload that the shuttle system takes to orbit, it's a fraction, a small fraction of the liftoff weight. If you count the orbiter and its payload as a payload, it's still a relatively small fraction. And I mean probably a 1/10%. So every bit of weight you put on that vehicle costs you useful payload. Now, to hang 10 ejection seats in the orbiter, yeah, we could have done it. We could have been shooting people out in all directions. But how do you tell them to shoot out? When that O-ring leaks down there and that thing blows up, you haven't got time to get out of there. And if you blow out, you're blowing yourself out right into the fireball. So we could never convince ourselves that you had to have a, quote, active abort system. We thought it was reasonable to build the vehicle the way we did, put the redundancies in it, carefully measure the loads, carefully measure the aerodynamics, carefully monitor the rocket system, carefully monitor the TPS, and it's still a risky business. And even if you had ejection seats, it'd be risky, and some of those goddamn seats might go off when you didn't want them to go off. Wally Schirra had an ejection seat when that Titan shut down on him, but he didn't punch it. He said, I'm going to wait till this thing falls over before I punch an ejection seat on this thing. So how do you know when to punch it? We used to talk, sounds silly now, we talked about a fortress booster We said these two JTO bottles, 2 boosters that we build, are going to have safety factors that make them a fortress booster. When the Air Force figured out how much insulation it had to have to handle the different burn rates, to keep it from burning through in one part before another and heating up the metal structure, they would put a 1.2 safety factor on their insulation. We put a 2. We put twice the insulation that our worst set condition said we were going to burn through before we finished the SRB burn. We went to high safety factors on the case. We went to 2 O-rings. We thought that was safe. But when that structure started flexing to where it opened up the second O-ring, something should have been done to fix that. They shouldn't have signed off on that damn thing. They should have fixed it. But we all know that now, right? So, I don't know. I wish we could have had a genius escape system that anytime anything goes wrong on the shuttle, takes you out. But I tell you, when you start entering that atmosphere at 25,000 feet per second, I don't know what kind of escape system you can have. And when you light off those SRBs, you're going. And you better go or you ain't going to get there with any payload. So that's the horse we're in. I don't know. Owen, can you help us with an abort system?
Not on that big, no.
More and Doc is the one who pushed the hardest for the wall.
I can't hear you, guy.
How come we couldn't shut the SRBs down? If anybody else said you can shut them down. Anybody else said SRBs shut down, you don't want to do that while you're flying in the vehicle.
You can't shut an SRB down.
Yes, you can.
You can blow out and neutralize the
Because you sit up there, you have a frangible diaphragm up in the front and a nozzle up in the front. And when you first slap there, the pressure drops and the film goes up. But it...
It's a thrust neutralizer. It's a thrust neutralizer.
Huh?
It's not a, you don't shut the SRB down.
Well, it does shut them down basically.
Well, they might go out accidentally, but now that stuff's burning. Hey, we're gonna change for these now.
To give you some numbers, the payload over shuttle is about 1% of the liftoff weight.
Payload is in the payload bay?
Yes.
Yeah, I know, it's what, nearly 1.6.
Also, the rule of thumb we used to use was 10 pounds on liftoff was equivalent to 1 pound on the ET or the orbiter.
I remember that one, but yeah. Anything else? I don't know what our time is. I've been trying to watch for 8:30. I'll stay here at midnight. It's up to you. Question?
The guy over here didn't show you.
Yeah.
How was the decision made for STS-1 for it to be a manned, the first test flight to be manned?
How was the decision made? Very careful.
I'm sure carefully, comparing like Gemini and Apollo.
Let me try to answer that honestly to you. A lot of very capable people were very concerned about that. And I knew that. And we looked at that very carefully. We looked at all the other failures. A lot of failures you get in the system come on the third flight, not the first flight. The seventh flight, not the first flight. Number one. Number two, we've been in the space business for 10, 15 years. And we did a lot of things like selecting electronic parts, for example, or controls of things. We almost go back to the mind and make sure we understand what's in the system. When we looked at all the things we did to try to put the reliability we thought was necessary in the system to get the safety, we also felt that having a person there with the food added a hell of a lot to change the success rate. And it was worth a lot more than the risk we were putting those people to. Now, a lot of people didn't agree with that. One of them was Bob Gilbert. Bob always felt we should go unmanned first time. I promised Bob we would do a thorough review Was it a smart thing to do? In retrospect, I think it was, because we did not spend a lot of money putting a lot of electronics in there, or software in the electronics, to run the thing automatic. And we didn't fly without the judgment of two people on board to fix the kind of things, to do the kind of things they could. Did they take a risk? Yes. But let me tell you, anyone who flies any vehicle that goes through orbit, as long as any of us are going to be on the face of this earth, is going to take some risk. And we just felt most airplanes, people are flying. And we thought this thing of building the ability unmanned and manned was an unnecessary activity. So we didn't do it. Now, those are judgment calls you have to make. And I used to say that's the reason they pay us so much money. Now, if another generation wants to do it another way, it's up to them. But we agonized on it, but we never wavered from it.
Got a question over here. It's okay, I've got about 5. I was wondering, the Constellation program right now, one of the main things that's on everybody's mind is the mass margin situation, especially for Orion and for going to the moon. So I was wondering if you could talk about the mass margin situation through the development of Shuttle, all the way from the beginning development, what your margins were looking like through the first launch.
I'm sorry, but I did not pick up what you said.
Sorry. I was wondering if you could talk about the mass margin situation through the development of Shuttle. That's a big deal for Constellation right now. So I'm curious the sort of things that you had to deal with regarding eliminating lots of things solely due to the weight.
How we handle mass, weights, good
Yeah.
question. I meant to cover that and sort of forgot about it. When we embarked on building what you now know as a shuttle, we were in a position where we looked at the technology of the engine, technology of the orbiter, technology of the tank, technology of the SRBs. We decided we could start the engines first, get it going, then start the orbiter, get it going, then start the engine or the tank, get it going, and then start the SRBs, get them going. So we started the engine, then we started the orbiter, we held off on the tank, we held off on the SRBs, didn't let those contractors inside. The engine was running pretty well, and we had a 19,000-pound, I believe, target for each engine. I kept talking to J. Thompson, do you need more weight? No, I don't want any more weight. 19,000 pounds is enough. He never came to ask for another pound. Orbiter. Started on orbiter. The only big weight thing I think we ever did in orbiter, we went to a titanium thrust structure that saved us 700 or 800 pounds, which was a really big weight problem after we estimated the orbiter. Then, when we knew those two weights, we sized the tank. Then, when we finished all of that and had more experience on what the thrust level out of the engine was going to be and what the weights were, we sized the SRB. Then we were so sure of ourselves, we left some space in the SRB to add more propellant if we were wrong. And we never had any weight problems. Weight problems, I mean, we didn't Kim Mill anything like they did in the lab. No, I'm not throwing rocks at it. Any other questions? I think, well, let me finish. Since I'm not, no one's going to fire me, I know, except my wife. I think Constellation on Ares 1 and the capsule will make a big mistake. You don't fix both ends of a solution and then go to work. You'll almost always have weight problems, number one. Number two, there's a limit to what you can do with a parachute. We bumped into that almost in Apollo. And I bet you're bumping into it in spades and Constellation, I don't know that. I don't have any out here. But anytime you fix both ends of weights prematurely and then start charging off, you inevitably have weight problems. And I'm not surprised you got weight problems.
Yes. I had heard that the decision was made to fly DoD payloads on the shuttle. That made quite a change in the requirements and the capabilities of the system, which had an impact on cost and schedule, those sorts of things. Is there any truth to that, or?
To fly DOD payloads.
Yeah.
Okay, let me be as constructive as I can. The rumor that DOD made us put bigger payload on the shuttle, or a bigger payload bay in the shuttle, made us do some things in the program that we didn't want to do, is absolutely wrong. Now let me explain that. At the time we sized the shuttle payload bay, there were lots of arguments. If you make it smaller, it'll be lighter. You take the payload bay from 60 feet down to 35 and put an airplane around it, you got the stubbiest looking little orbiter you've ever seen. It doesn't look very good aerodynamic, number one. Number two, we've had lots of arguments on whether you're going to build a modular space station or a great big rotating Saturn V launch station. We were going to build a modular space station. We've done some modular mock-ups here. A 45-foot length made us a nice module. We like it. 15-foot diameter made us a nice one. We like it. We could live with 30 feet. We could live with 10 feet. But we like 45 and 50. You put a 40-foot module in the payload bay, and you put an airlock in the payload bay, and a docking interface in the front of the payload bay, you got 65 feet. NASA wanted 65 feet. The Air Force liked 65 feet. Now, we've been stupid to say, we don't like you, Air Force, we're going to build a 30-foot. Then when Nixon turned to Weinberger and says, hey, y'all, and you use the shuttle, he said, hell with those people. We weren't interested in that. We cross-range. Cross-range means as much to NASA as it did to the Air Force. Look at our abort during launch. How much cross-range we use to get to the aborts. The transatlantic aborts. Look at the times we come and have to use cross-range to go where we're going to land. Plus, we begin to fly the vehicle early enough that the pilots are comfortable with it. We put one thing that I can remember in the shuttle that was Air Force unique, and that was some insulation on some wiring so that they could have some secure communications. And it was an absolutely minor thing. Now, why didn't the Air Force use the shuttle? If you got time, I'll go into that. The time we were getting ready to build the shuttle, you know, the Air Force is a big organization too. And there were some people in the Space Command in the Air Force who were trying to get into the manned business. They tried to get Dinosaur, they got killed. They had Gemini, Blue Gemini, they got killed. In any event, there were always people in the Air Force who were like to have gotten into the manned business. But each time they convinced themselves that men flying up there could do something, the people figured out how to do it quicker and better unmanned. So they kept losing out. So the Air Force was very interested in flying the shuttle. They spent a lot of money out in Vandenberg on Split 6. By the time it came time to fit their payloads into NASA's shuttle program or into their unique shuttles, their unmanned program had solved all those problems. They didn't need a man. And so this Secretary of Defense said, I don't want to spend money on a manned vehicle. I'm doing everything I want to do without it. So they shut it down. But they helped us by cooperating very nicely with us. We had Air Force people here the whole time we developed. They were on the source selection board. They were very constructive. We had a good relation. And they did not force us to do a thing we didn't think we had good logic for doing. But we did put that one bit of insulated wire in there that we might not need.
You were talking about escape towers. Can you foresee, a someday launching manned spacecraft without the tower?
Pardon me?
You were talking about escape towers.
Escape towers?
Yeah. Can you foresee us, building manned spacecraft someday, without the tractor?
No, I wouldn't say that. I think if you are content to package your people solid enough in a capsule, and you look at the reliability of your systems and everything, and over and above that, you'd like an escape tower that can pull its rays, and if you can afford that weight, and you can split free, and you can figure out when to fire it. Nothing wrong with the skate tires. We got them on work, got them on jump. But I will almost defy you to build something that has the capability to shuttle and put a skate tire and pull people out, pull it off. No. In 130 flights, I don't think it's been necessary. But one program manager or one program management group does one thing, one does another. I'm not condemning a skate system or board system. I'm just saying they're not the panacea for everything in the world. Long term.
Okay, why don't we just take one last question?
I just want to know what surprised you about STS-1. After the flight was over and you looked back at the data, was there something in it that surprised you?
Something that surprised me?
In its performance or?
Something, you mean in a negative sense or a positive sense?
Either way.
Well, it's arbitrary. I'll give you a positive. I don't give you a negative anymore. It's positive. I think the show, how long has it been flying? 27 years. If you allow me to set the two accidents aside, which is not fair, but I'll set them aside, I think it's been one hell of a good system. And I think we developed it pretty well in the time and in the money we said we were going to develop it. And frankly, I think we've been able to manage the thing. We missed a lot of it. Again, I left the program before this completely here, but my understanding is that we missed a fair amount of the aerodynamics. The aerodynamics before launch wasn't as accurate as it might have been. There was some so-called real gas effects that we weren't smart enough to really know what the air was going to do when we were chemically changing the air. But we had enough tolerance in our control system, and enough tolerance in the trajectories we were flying. We had enough muscle in the reaction control system to fly the thing even when we missed the aerodynamics. We missed the aerodynamics probably more than I thought we should. Another reason we missed it, it's hard in a wind plane to simulate thrust effect. I did some work back in landing before I got the space program. We were trying to figure out the aerodynamics on supersonic airplanes, with engines embedded in the wing. What's the aerodynamics of that wing in the presence of that exhaust gas? It's tough to simulate in a wind tunnel. It's tough to get all the effects. So the thrust effect on the aerodynamics and the real gas effect on the aerodynamics caused us to miss the aerodynamics farther than I thought we should. But we were flying in speed ranges and flying with configurations. It's not easy to measure in the wind tunnel or easy to analytically predict the effects. Maybe the analytical techniques are better to predict. But I think we missed the aerodynamics, but we didn't miss it enough to kill us. I don't know. What do you want, Al? What do you think?
I don't really think there were any real big surprises from STS-1. I let the program before that, but to me, the big surprise was we didn't have any very big problems.
We were in the bucket as hell or I'm not sure what it was, but it worked out so well. Anyone else? Over here.
I think that's all.
The question is that there were 5 orbiters, and none of them that actually flew were named Enterprise. Did you catch any backlash from the Star Trek fans for that?
I didn't hear what he said.
One space shuttle that was named Enterprise that did not fly into orbit. Was any Star Trek fan mad at you?
Oh. Gee, I don't know. They probably were.
Okay.
Seems to me like there was something that came out around that naming. I don't remember. I think we had a name for it, and then someone in Washington decided to put it out on competition, and they named it Enterprise or something. I'd rather answer an F=MA question.